What's going on, you guys? Mr. Allen here, about to write some functions in standard form that contain the following roots. Now, this first one here, I have 2 plus root 3, which means I'm also going to have 2 minus root 3. It's conjugate. Now, the way I remember this is if I think about the quadratic formula, right, that'll give me some answers with square roots in them, right? Well, it's opposite to be plus or minus the square root of b squared minus 4ac all over 2a. All right, so it's plus or minus that radical, that square root. So if I'm going to have one, I got to have the other. So we got 2 plus root 3, and then we have 2 minus root 3. Same goes when we're talking about imaginary numbers, but we'll leave that for another time. All right, so I've got these 2 roots right here. So I got a quadratic because I have 2 roots. Now I'm going to start by writing it in factored form, multiplying out to get it into standard form. So let's say I've got, let's see here, x minus this first root here, which will be 2 plus root 3. And then I'm going to have x minus 2 minus root 3. So I got my other root right there. Now, I know this looks kind of weird, right? With all these, like, why are we subtracting that? Well, if I had, like, say, x equals 7 as one of my roots, then my factor would be x minus 7. If I had negative 3 as one of my roots, then x minus negative 3 or x plus 3 is one of my factors. Cool? So the same thing applies here. It's just super messy. Now, I'm going to go about this in a somewhat creative way of grouping things, but the first step is distributing, all right? Same goes with this one here. So now I have x minus 2 minus root 3 and x minus 2 plus root 3. Now, what do we see here? Well, I see an x minus 2 right here as well as right here. And then it's just minus root 3 or plus root 3. This is kind of like difference of 2 squares, where if I had, say, something like x plus 7 and x minus 7, when I multiply this all out, my 7 times x and x times negative 7 cancel each other out. The inner and the outer cancel each other out in the whole foiling process, right? So if I group these in a creative manner, I can actually use what I'm talking about right here to multiply this out. So I've got the first part of x minus 2 and x minus 2. So when I multiply those two together, I'm going to have x minus 2 squared, or I'll write it out as x minus 2 times x minus 2. Now the x minus 2 times root 3 and negative root 3 times x minus 2, those are going to be canceling each other out when I multiply it all out. So I'm not even going to worry about those. It's a huge mess anyways. So there we go. I don't have to worry about the outside or the inside because of what's going to happen. And then I have negative root 3 times positive root 3 is negative 3, right? Root 9, 3, beautiful. So now we just have to FOIL this guy out, combine some like terms. So x times x is x squared minus 2x plus 4 minus 3. And finally, we're going to have x squared minus 4x plus 1. It does say write the function, so we'll call this one f of x equals. Don't want to lose half points on a test for not using function notation if they're asking for it. All right, there we go. First one done, guys. Next one, kind of the same idea here, but we do have that bonus root right here. So we're going to have 3. We're going to have negative 1 plus root 7, and we're going to have negative 1 minus root 7. There we go. All right, so we have 3 of them. It's a cubic. Let's write it out in factored form first. I'll start even with we'll call this one g of x equals. All right, so I'm going to have x minus 3. That one's easy. We're not going to really deal with that one much until the very end. All right, now the next one, this is where it gets, right? So we're going to have x minus negative 1 plus root 7, and then x minus negative 1 minus root 7. Boom. All right, hopefully that all fits there. We're good. All right. So now, let's multiply some things out. Again, I'm not going to touch this one for a bit, so we'll just leave it there. You can either like draw an arrow and write it down there, but don't forget it because it is important here. All right, now I'm going to deal with this whole mess right here. So we got to distribute the negative, which means I'm going to have x, and then we'll have plus 1 minus root 7. And then here I'm going to have x plus 1 plus root 7. There we go. All right, so now we're going to group these things, okay? So I got my x plus 1 and my x plus 1 that is the same. So I'll throw in some parentheses there and there. And now essentially I'm just foiling this as almost like 2 binomials here, even though it is a trinomial. There's 3 different terms there, right? But I'm taking this as a term and this as a term, and then my root 7s as the other one. So once again, the x plus 3 stays, or sorry, x minus 3 stays. And then I'm going to have x plus 1 times x plus 1 And then we have negative root 7 times positive root 7 is minus 7. Nice. All right. Now, still keeping this guy here. Don't want to forget it. I'm going to FOIL out my x plus 1 times x plus 1. And we should get better at this and be able to do this and the combining of like terms in our head and not have to write it all out. It will definitely save some time. So x times x is x squared. Then I'll have 1x and 1x is 2x. And then plus 1 minus 7. We're getting there. X minus 3 one more time. And now I have x squared plus 2x minus 6. So we're still in factored form. Sometimes they'll allow you to leave it like this. They'll say like in factored form with integer coefficients, right? No radicals, no imaginary numbers. But since this one does say standard form, we got to multiply it out. So I'm going to have, let's do a different color here. So we got x times x squared. That's going to give me x cubed. Then we got plus 2x squared minus 6x. And then the other one, I'll do that in orange. We got, and I like to do this actually, okay? If it's all written like in, descending order in these factors, I can actually write it below its like term. Makes it a little easier to combine like terms later. So I got negative 3x squared, and then we have negative 3 times 2 is negative 6x, and then we've got ourselves, what, positive 18? There we go. So now, as you see, I've got everything lined up where it needs to go. I don't have to like search for it. That works really well when it's, again, in descending order for each one of these factors, highest degree to lowest degree. So I got x cubed. And then we have, what is that, minus x squared minus 12x plus 18. Boom. Diggity. G of x. Dope. Done. Like it. Nice. Cool, man. That 3 kind of got jacked up a little bit right there. There we go. It's back. Cool. All right, so there we go, guys. Writing functions in standard form given roots that are containing radicals here. I mean, these problems are quite radical, if you know what I mean there. All right, that's about it. Have a wonderful day, guys, and stay dope.